All right, also, like I said, 7.4, we're looking at quadratic equations. So quadratic equations have these x squared terms. And the highest exponent will be a 2 for a quadratic equations. And if you remember when we graphed the quadratic equations with the x squared terms, when we graphed them, we got our parabolas when we graphed those, okay? So we're going to start playing with these quadratics and the parabolas and all that fun stuff. So first, I'm going to give you a few definitions. So zeros. When we say zeros, we're talking about the solutions to a quadratic equation. And y'all, the reason we call them zeros is because we find the x values by setting our equations equal to 0. So given ax squared plus bx plus c equals 0. So given a quadratic equation, y'all let me let one in real quick. So given a quadratic equation, the solutions of the quadratic equation that are obtained by setting the equation equal to 0. Okay, so we'll take the functions they give us, set them equal to 0, and then solve it. Okay. Now, another thing about the zeros are equal to the x value of the x-intercepts of the graph of the equation. Okay, so I'm gonna play with that a second. So remember, to be an x-intercept, the y value has to be 0 for x-intercepts because that's where they cross the x-axis at. So I'm going to draw one of those and show you what we're talking about. Alrighty, and say I got me a parabola. My parabola is crossing over here at -2. And then let's say it's crossing on this side at the 3. So my parabola is going to come down, sort of swing around and come up. So where these parabolas cross the x-axis, we call these our real zeros. Okay. Now later on, I'll show you what imaginary zeros are. But real zeros cross the x-axis. So for this parabola, I'm going to find the x-intercepts. Then I'll show you what the zeros are. Okay. Now, this point on the left side, it's at -2 on the x-axis. So that x-intercept would be -2, 0. Remember, any point on the x-axis has a y value of 0, just like we're setting the equations equal to. Now my second x-intercept is over here at 3. So that one would be 3, 0. So when you do these kind of points for the x-intercepts, remember they got to come in parentheses like an ordered pair and then separate them with a comma. Now remember up here I said, hey, the zeros are equal to the x value of the x-intercepts. Well, the x value of the first x-intercept is -2. So -2 would be one of my solutions or zeros, and then 3. So what that means is if you're weak at factoring and solving quadratic equations, you can graph these, and if it crosses the x-axis, you can find the solutions, okay? Now, sometimes we got a quadratic equation, and say it sits over here like this. But notice this parabola does not cross the x-axis. So when a parabola doesn't cross the x-axis, that's where we're going to get what we call imaginary roots or imaginary zeros. How about that? So imaginary zeros because it don't cross the x-axis. So that's where all this is going to lead. If it crosses, they're real zeros. If it don't cross that, then we'll get imaginary zeros, which would be like 2i, 3i, and all that fun stuff. And I'll show you how we get those type of zeros when we start solving these quadratics, okay? So y'all, let's look at ways to solve quadratic equations. So the first way to solve these quadratic equations is by factoring. Now, when you solve by factoring, that could be as simple as factoring out a greatest common factor, or it could be factoring trinomials into the two sets of parentheses like when you were foiling. So factoring undoes the distributive property and it undoes foiling. Okay. So trinomials are the trickiest. So I'm going to show you the 4 sign patterns based on the signs. So the first pattern, x squared plus bx plus c equals 0. So everything's positive. Next, we'll do an x squared minus bx plus c equals 0. Now, here's the thing. When the last number is positive, like the c, when the c is positive, this is going to factor into an x plus and an x plus. So if the last one's positive, both of these factors will have the same sign as the middle number. Same thing on this one. The last one's positive, so both of these factors will be negative like the middle number. Okay? Now, I always focus on these pluses. When the last sign is positive, we're going to find factors. We're going to find factors of c. Well, factors of c, which is my last number, that add to equal the middle number. Or how about this? That add to equal b, since b is my middle number. So I'm going to find factors of the last number that add to get b. And it don't matter where I put them because both of these are positive and both of these were negative. So if the last number's positive, we're going to have these two types of scenarios. Now, let's make the last number negative. if the last number is negative, and both of these, notice, have a negative at the end, no matter what, when the last number is negative, you're going to have unlike signs on your factors. So there'll be unlike signs because remember, when you multiply a negative times a positive, will give you that negative. Now, here's the difference. Because these both got a plus and a minus, but we don't know where to put our numbers yet. So what we do, since that's a minus at the end, I'm going to find factors of C that subtract to equal B. So I'm going to find two factors of this last number that'll subtract and get me to B in the middle. Now, here's the kick on this one. The larger factor has the same sign as B. Okay, so this is talking about the trinomials. So greatest common factor stuff is still at play and all that kind of stuff. So in a second, we'll start doing some factoring, and these are what I use to factor those back into my parentheses, okay? All right, the second way to solve quadratic equations, I can solve by square roots. So solve by taking square roots. Now, y'all, the thing about the square roots is, in order to use the square roots, you cannot have an x term in the middle. So cannot have the x term in the middle. So it's going to have to be like an x squared and a number is all that can be there, okay? We cannot have the x term. And solving by square roots, is how I turn an x squared into an x, sort of like we did when we was playing with those inverse equations. And I said, well, if you had x squared, you took square roots to undo those. Okay. So we'll play with this. This will be more in the support section. All right, y'all, my third way to solve quadratic equations, and this is the one the college algebra will focus on the most, this third method, and that is solved by the quadratic formula. Okay, so quadratic formula, if we're in the form of, so given ax squared plus bx plus c equals 0, the solutions can be obtained by the formula. And y'all, here comes that formula. X equals negative b plus or minus the square root b squared minus 4 times a times c. All of that is over 2 times a. So we plug in for the numbers that are in front of the variables and this number at the end. So the a will always be in front of the x squared term. B will be the number in front of the X, and C will always be that constant number at the end. Okay. Now, since you got an X squared as the highest exponent is a 2, that tells you got to get 2 answers out of these type equations. Now, the way the quadratic formula gets the 2 answers is with that plus or minus. The first time we go through, we add and then divide. And then the second time you come through and subtract what you get from the radical and then divide. So that's how it gets the 2 answers here, okay? Because what you got to remember, the square root of 4 can be 2, because 2 times 2 equals 4. Square root of 4 could also be -2, because -2 times -2 equals 4. So that's why when we take square roots, we're going to start putting the plus or minus. That's how we get our 2 answers we need, okay? So quadratic formula, and just like factoring, you got to have everything on one side equal to 0. The only one you don't have to do the 0 on is the square roots, okay? But if it's got 3 terms and we're using the quadratic formula, we got to get a 0 on the right side. So y'all, let's see what they're hitting us with first. So now we're going to look at some of the 7-4 homework for college algebra. So my number 1 says, hey, find the zeros of f of r equals r squared plus 11r plus 30. All right, so I'm going to check and see if I can factor this, because if I can factor it, that's the quickest way. Now, this quadratic formula will work on every single quadratic equation, okay? But look at it, it's a little more complicated, okay? So let's take this r squared plus 11r plus 30 and set that equal to 0. So y'all, if this is going to factor, remember, since this is plus at the end, if this is going to factor, I would have to find factors of 30 that add to get 11. So I need factors of 30 that add to get 11. So y'all, is that possible? Can I find 2 factors of 30 that'll give me 11 when I add them?
Yes, 6 and 5.
Yeah, 6 and 5. Good job. So 6 and 5 will give us 11. So what we do, so the chat was popping up. Good job. So what we would do then, since there's an r squared in the front, we're going to put an r here and an r here. And remember, we said if the last one's positive, both factors will be positive like the middle number. And then y'all told me, hey, the factors of 30 that get 11 are 6 and 5. And since they're both positive, it don't matter where I put the 5 or the 6, okay? But y'all watch this. 6 plus 5 gives you 11. 6 times 5 gives you that 30. So now that we've got it factored, we're going to solve it to get the 2 answers. Now, y'all, we're going to use what we call the 0 product rule. The 0 product rule says that if this factor, if I can get this to equal 0, then the whole thing would equal 0 when I multiplied. Or I can get this factor to equal 0, and when I multiply, the whole thing would equal 0. So 0 is the only number when multiplying that I can guarantee that one of those factors has to be a 0, okay? So this is what we call a zero product rule. So these two, we're going to take the r plus 6, set it equal to 0, and we'll take that r plus 5 and set it equal to 0. So once we solve both of these, we'll have our two zeros. So y'all, on that first one, we're just going to subtract 6 from both sides and be done with that one. So one of my zeros is -6. And then over here, let me subtract 5. And I get r equals a -5. So on that one, we would MathLab would have the solutions are blank. We'll just put in a -5, comma -6, and be done. But y'all watch this. Remember, I said that these zeros, if you was looking at a graph, see if y'all was paying attention. Since these are the zeros of this equation, where is it crossing this x-axis at? Well, y'all, guess what? I got a graphing calculator, so what I'm about to show you. So let me pull up my share here. So I'm going to go to y equals. Now notice, on the calculator, I can't use r's, so I got to use x's on it. But r squared would be my x squared, plus 11r would be my 11x, plus my 30. Let's look at the graph and see where this is crossing the x-axis at. Because remember, those are two real numbers. And y'all look at that. Over here, there's -1, -2, -3, -4, -5 is crossing that. And if you go left, that one's crossing at -6. Now watch what the table looks like. Second graph to pull up my table. So let me go up there to where that -5 and -6 were sitting at. So look at that. When x is -5, y is 0. When x is -6, y is 0. So that tells me that -5 and -6 would be the solutions to this. So if you're weak at factoring, you can always graph it and get an idea where those zeros are, okay? Or those solutions. Remember, zeros are solutions, okay? So just a way to so that was over here at what, -5 and -6. That's where my parabola sort of came through and then went back up. Okay, so these are the zeros, and the zeros are the same as the x-intercepts, okay? All right, y'all, let's try this one. Find the zeros of f of x equals x squared minus 14x minus 4. All right, so I'm going to set this equal to 0 real quick. So x squared minus 14x minus 4 equals 0. So y'all remember, this last one's negative. So if I'm going to be able to factor this one, I have to look for factors of 4 that will subtract to get 14. So is that possible? Right, Hannah, good job, because there's no way I'm going to find factors of 4 that are going to equal 14. So this one does not factor. So guess what? Since this does not factor, we're forced into using that quadratic formula. So it does not factor. So we got to use the quadratic formula. So first, remember, because we got to figure out what A, B, and C are to put them into the formula here. That 4 is always in the formula, and that 2 is always in the formula. So we got to figure out A, B, and C to put into that. Well, A, B, and C are going to be the numbers in front of everything. So y'all, I don't see a number in front of that x squared. So what's that going to make your A?
1.
Right? So 1 is good. There you go. B is in front of the x, so that's what, a negative 14. And then C is the constant term at the end, the number, we call that. So that's negative 4. All right, so there's A, B, and C. So now let's plug them in. Now, y'all, guess what? That negative is always in the formula. So write that negative first. And then my B is a negative 14. So I'm going to put my negative 14 in parentheses. Then I got my plus or minus. And then our radical. Under the radical, B squared, that's going to be negative 14 squared. Minus 4 times A, which is 1. And C, which is negative 4. All of that is over 2 times A, which is 1. So now you see why I hope they factor, but if they don't factor, then this will solve it, okay? So really, this negative up here, its only purpose in life is to change the sign of whatever your B is. So since my B was negative, that negative times that negative is going to make that a positive 14. Then I got my plus or minus, my square root. All right, so under here, any number you square will be positive. Okay, so a negative 14 times a negative 14 gives me a 196. Now y'all look at this. Everything on this right side here is being multiplied. That negative 4, 1, and negative 4. What sign will come out of all that being multiplied? Because let's see, we got what? 2 negatives? Oh, I just heard you. What did you just say?
A positive.
A positive. There you go. And then let's see, 4 times 1 is 4, times 4 is what? 16. All of that over 2 times 1, which is 2. So we're getting there. Notice a lot of the work is up under that little radical part there. So I can't do nothing with the 14 right now, plus or negative. Square root, 196 and 16, that's going to give me 212. All of that over 2. So y'all, here's the thing now. We got to simplify this square root if it simplifies. So what I'm going to do over here is play with that on the side. My square root of 212. So y'all, here's the thing. To simplify a radical or a square root, that means I have to remove all factors from under that radical that might be perfect squares. And y'all, I'm about to show you what perfect squares are. So these are the numbers you're going to look for, the perfect squares, when you're simplifying these radicals. So perfect squares are numbers that have a square root, okay? Now, 1's a perfect square, but it's not going to help me do any of these problems. But the next perfect square would be 4. Because y'all, square root of 4 would be 2. Next would be 9. Square root of 9 is 3. And I'm just going to keep going. Square root of 16 is 4. Square root of 25 is 5. So notice, all these numbers I'm writing, you can take square roots of them all. And I'm just going to go to 225. So square root of 225 would be 15. Square root of 196 would be 14. Square root of 169 will be 13, 12, and so on. So here's the thing. I need to see if this 212 will divide by any of these perfect squares and give me a integer. I don't want decimal answers. They got to divide evenly into this. So if you take 212 and divide by 4, you'll get 53 out of that, which is not a decimal. If you divide by 9, you'll get a decimal. Anything else you divide by, you're going to get decimals. So the only perfect square factor of 212 would be 4. So you would come down here, write your perfect square 4, and then I multiplied that by, when I divided 212 by 4, I got 53. Now, under the radicals, 4 times 53 still equals 212. But we brought out this perfect square of 4 because what is the square root of 4 going to give us? It's going to give us a plus or minus 2. Remember, 2 times 2 is 4. Negative 2 times negative 2 is also 4. So anytime you take square roots of numbers now, you're going to put a plus or minus in front of them. Now, the 53 will not divide by any of these other perfect squares. So we know we've went far enough so that square root of 212 simplified into a 2 square root of 53. So now we're going to replace this square root of 212 with that. So y'all, that gives me 14 plus or minus 2 square root of 53 all over 2. All righty, now, if this is going to simplify further, I'm looking at these 3 numbers in green. So for that to simplify, all 3 of these numbers on the outside have to be able to simplify. So basically, this 2 affects both the numbers on top. So I would take the 14 and divide by 2. That would give me a 7 plus or minus. Here you got 2 divided by 2, which is 1. So that's just going to give me 1 square root of 53. Remember, I don't have to write the 1, okay? Any other number I would have to write in front of that, but since I got a 1 out of that, I can do that as my final answer. So y'all, here's the thing. First answer. The first answer would be 7 plus square root of 53. My second answer is 7 minus square root of 53. And y'all, I'll tell you what, Math Lab is nice. They'll let you put it in as this, using the plus or minus. When you got radical answers left, it'll let you do the plus or minus for shorthand instead of actually writing both of these answers, okay? But that's what that plus or minus means, is that one answer I get by adding, one answer I get by subtracting. All right, y'all, so for these problems, keep up with these numbers because those are my perfect squares, okay? So y'all, let's try more. So let me fix my paper here. All righty, let's see what I got here. x squared plus 7x minus 5 equals 0. Now check this one out. This one wants me to find exact answers. And it wants me to find decimal approximations. So find approximation, 3 decimal places. So the exact answers will probably have the radicals, and then the approximations, we're going to turn that into decimals, okay? So let's see if we can factor this one. Can I find factors of 5 that'll subtract and get a 7?
No.
No. So here we go. We're going to find A, B, and C again because we get to use our friend, the quadratic formula. All right, y'all. A was 1. B is 7. And C will be -5. So let's plug that in. So negative B, this time B is positive. So that negative is going to turn it into a -7 plus or minus square root. B squared will be 7 squared minus 4 times 1 times that -5. All of that over 2 times 1. All right, so 7 squared minus 4 times 1 times -5 is under the radical. So y'all, let's see. Can't do nothing with the -7, so bringing it down. Got my plus or minus. All right, we know what 7 squared is. That'd be what, 49. All right, y'all remember, you're multiplying this whole right side. So what's that going to give me? That -4, 1, and -5.
It's gonna give you 20.
So that's going to be a positive 20. Good job. And then on the bottom, 2 times 1 is 2. So usually you'll either have 2 negatives in these or 1, determining whether it's going to be like positive or negative. All right, y'all, let's add the 49 and 20 under the radical. So 49 and 20 give me 69. All of that over 2. So now we're doing the side work, and we got a square root of 69. All right, remember, I'm going to see if it divides by 4. No, it'll give you a decimal. Does it divide by 9? No, it gives you a decimal. Does it divide by 16? No, it'll give you a decimal. What's next? 25? Well, it don't divide by 25. Next, I will try 36. No, it don't divide by 36. Woo, what's next? 49? No, it ain't going to divide by 49. Everything else is getting too big. So this one does not simplify. So since that radical does not simplify, this right here would be our final answer. And this is called the exact answer. Now remember, they also want me to find the decimal approximations. So what I got to do is do this twice. So here's for my first one. I'm going to take the -7. I'm going to add a square root of 69 and then divide by 2. Now, decimal approximation, since it's being rounded off, that's when they use these little curvy parentheses. That means we're sort of rounding stuff off. Now, remember, I'm going to do this on the calculator because square root of 69 is a never-ending decimal, okay? So no way I could figure that out in my head. So I'm going to go to my calculator and show you what I would do to that. So y'all let me quit this screen here. And I'm going to clear my history over here. So I want it to look like a fraction. I'm going to hit the alpha green button and hit y equals. And I'm going to hit enter for number 1, n over d. That's going to make it look like the fraction. On top, I had -7 plus square root of 69. Well, the square root is the blue second button, and then the x squared button. And then under that was a 69. Now I'm going to arrow out of that and go to the bottom. And on bottom, all we had was a 2. So y'all look, it looks like the -7 plus square root of 69 over 2. So I'm going to hit enter. Round me off 3 decimal places on that. What do y'all got? I see it 0.653, perfect. So the 3, the first 3 will stay at 3 because the number behind it is less than 5. All righty, so let's go put that on real quick. So we got 0.653. Now we're going to get our second answer by doing -7 minus square root of 69 over 2. So y'all, let's go punch that one in now. So the same thing, except this one's being subtracted. So I'm going to go to alpha y equals and get my fraction again. Hit enter. On top is -7 minus square root, which is second x squared of 69. Arrow out of that and go to the bottom and put in your 2. All right, y'all, I'm going to hit enter and we're going to round this 3 decimal places. All right, y'all, 3 decimal places on this, and what do you got? Oh, you're so close. I need 1 more digit. Remember, they want 3 decimal places to the right. So -7.653, perfect. There you go. So yeah, when they want 3 decimal places, it's got to be to the right of y'all's decimals, okay? All right, y'all. So these are the approximations, and that, like I said, is the exact answer. So let's see what else they got up there for us. All right, this one I got f of x equals.
Mr. Mr.
Yeah, I
F
hear you.
how would it want us to write that one on the exact answer on the approximation ones?
Oh, they want it just like that.
Okay.
Yeah. Now you could write 2 answers by using the plus. You could write it like I got it right here in the answers if you want to, and put a comma in between them, because these are the exact answers. But that's a lot of stuff to write twice. So I always use the plus or minus on my exact answer. And then on this one, you'll do the 0.653 comma -7.653.
Okay, so that'll be one of those questions that has like 2 or 3 parts of it, and it wants us to break down the plus or minus part of the answer.
Mm-hmm.
Okay, I just wanted to make sure.
Okay. All right, y'all. 4x squared minus a x plus a 9. Now, when there's a number in front, it's a little trickier to factor these things. Now, I'll show you one in the support part when I got a number in the front, but I'm just going to tell y'all this one does not factor. And I'll show you how you can tell. Let me go to my graph and graph that real quick. All right, so I'm gonna go y equals and clear that out. So I had what, a 4x squared. So 4x squared minus x, and then plus 9. So I just want to see the graph, see what it looks like. Woo, so see, it barely is you can barely see the curl on the very top there. So that tells me it's not even crossing the x-axis, okay? So that means it's not going to have real zeros on this one, okay? So let's play with this. Remember, I said if it doesn't cross that x-axis, it's going to have those imaginary zeros. Oh, y'all, so this time A is 4. B is what, a -1. C is a +9. So let's plug them into our quadratic formula. X is going to equal -b, which is a -1, plus or minus square root. So notice I'm mainly putting my negative numbers in parentheses because those are the ones you got to be worried about, okay? So -1 squared minus 4 times A, which is 4, times C, which is 9. All of that over 2 times 4. All right, y'all, so watch this. -1, that double negative makes that a positive again. Plus or minus my square root. All right, y'all, -1 times -1 is a +1. Now, y'all, 3 things on the right side being multiplied. What sign will that give me? And I got what, a -4?
It's gonna give you a negative.
No, it's definitely gonna give me a negative. Oh, and let's see, that's what 16 times 9, I think that's like 144. All of that over 8. All right, one more step to play with that radical there. So I got 1 plus or minus square root. Well, y'all, that's going to give me a -143. All of that over that 8. So it's time to play with this on the side. So, y'all, we will take care of that negative, but I'm wondering, are any of my perfect square factors a factor of that 143? So guess what? It ain't dividing by 4, ain't dividing by 9, ain't dividing by 16, it ain't dividing by 25. Y'all, guess what? That 143 will not divide by any of my perfect squares. But here's the thing. We cannot leave that negative under that radical. So we're going to split this into 2 radicals. We're going to break out that negative as a -1 and then my 143. Okay. Now, do y'all know what I put in place of the square root of -1? Because remember, I still can't take the square root of a negative number because like signs are always positive. There's not 2 numbers that'll have the same sign that'll equal a -1. So what they said was, hey, we're going to let the square root of -1 equal I. That I stands for imaginary. This is telling me I can't take the square root of this 143 in the real world, but I can in the imaginary world. So this would break out as the I square root of 143. So if nothing else, if you got a negative under that radical, you will bring it out as an I, because that's telling me that these have to be imaginary answers in order to equal a negative, okay? So y'all putting that in, I get 1 plus or minus I square root of 143 over 8. Now, since I got imaginary answers in my problem here, what I got to do now is write this in A plus BI form. We call this a complex number. It's got the real part and it's got the imaginary part. So they don't like it as one big fraction when you got imaginary answers. So what we got to do is break this into two fractions. We're going to put the 1 over the 8 first. The 1 over 8 is the real part of this answer. Then we got our plus and minus. The imaginary part is going to be the I square root of 143 over 8. So both of these on top, we put them over to 8, okay? So now I got my real part, I got my imaginary part. And guess what? This right here is what MATLAB wants on that one. And that's why this one, remember when I did the graph? That's why this one was way up here. It's got imaginary zeros because it's not even crossing this x-axis here, okay? And we'll get more into those later in life. All right, y'all, let's see what we got. Let's do one more of these, and then I'm going to play with the support stuff. And I'm going to get y'all good at doing the decimals on this one. So they're giving us 3x squared minus a 5x minus 7 equals 0. So they want exact answers and decimal approximations. All righty, so this one's not going to factor. The way I tell on these kind, when it's got a number in front, I don't look for factors of the 7 that'll subtract to get to 5. When you got a number in front, you multiply the 3 times the 7, which is what, 21? And you look for factors of 21 that'll subtract and get 5. Well, y'all, the only factors of 21 are 1 and 21, which give me 20. And then what, 7 and 3, but they'll subtract and give me 4. So this one doesn't factor, so we're going to find our numbers. A is 3, B is -5, and then C is a -7. So since this don't factor, it'll probably either give me radical answers, which are real, or it's going to give me imaginary answers. So y'all, let's see what this one's going to do to us. So -b, which is a -5, plus or minus the square root, b, which is -5 squared, minus 4 times 3, which is A, and -7, which is my C, all over 2 times 3. So I got a little far over here, but this is -5 squared minus 4 times 3 times -7. So y'all double negative again. So it's going to turn that -5 into a +5. All right, under my radical, -5 squared is 25. Oh, and y'all look at that. I got 2 negatives. So let's see. That's going to be a positive. 12 times 7 is what? 84. All that over 6. All right, so let's add up under the radical. So I got 5 plus or minus square root. Y'all, that's going to give me a 109 all over 6. So let's play on the side with that square root of 109. Now notice, this one doesn't have a negative under here. So since it doesn't have a negative, I'm not going to get imaginary answers on this one, okay? So I'm seeing if that'll divide by my 4s, 9s, 16s, and all those perfect squares. Well, y'all guess what? It's not going to divide by 4. It's not going to divide by 9. It's not dividing by 16. It's not dividing by 25. And you can keep on going. It's not going to divide by none of my perfect squares. So this thing does not simplify. So since it does not simplify, this is my exact answer. But now we got to get those 2 decimal approximations. So remember, the first time I'm going to add 5 plus square root of 109 over 6. We'll see what that's going to give us. And our second answer, we'll do 5 minus square root of 109 over 6. And we'll see what that gives us. All right, y'all, so let's go to our calculator. I just want to quit the graphing screen. Clear that. Alpha y equals, and hit enter. So y'all had 5 plus square root, which is second x squared, 109. Arrow down to the bottom, and I had a 6 on that one. So y'all, 3 decimal places for my first one. That's what, a 2 point, what's that, 573. Got a 3 after it, so we're going to leave that 2.573. So now my next one, hit alpha y equals, enter. And that one was 5 minus square root of 109. Whoops, too many 9s. So let me go back and delete that one. All right, go to the bottom and put in my 6. All right, y'all, so let's see what this one gives us. I get a negative point. So what's this one? 3 decimal places, y'all. See what y'all put. Negative. Well, I like the 907, but where y'all getting that 1?
Would the 9 not round up on the left side of that decimal, or no? It only
Oh,
applies.
no, we're just looking for the, so only way that 9 would round up is if that 0 was a 5, 6, 7, 8, or 9.
Okay, so just to the right side of the decimal.
So just go to the right side, and that 6 will turn into a 7. But remember, that's like a 0.907. So if there's not a number in front of the decimal, make it a 0 on those, okay?
Okay, so negative 0.907.
So you could do like this, yeah. All right, y'all, so I'm going to start playing with some of the support stuff that you're going to see. Okay, so let me get my page here. All my papers are turning up. All that writing I'm doing on them. So the support will sort of play with factoring and the square root stuff I was showing y'all earlier. So this will be 7.4 support. All right, so number one says solve 11a plus 5 times parentheses 5a minus 15 equals 0. So they've already got a 0 here. So this one technically is already factored like I did a while ago when I did the R's with y'all. And I think we had an R plus 5 and an R plus 6. Well, since this is already factored and it's already set equal to 0, we can take both of these factors and set them equal to 0 to get our two answers. So we would come in and do 11a plus 5 can equal 0, or this 5a minus 15 can equal 0. So they're just showing you what to do with parentheses before we actually factor one in the support, okay? So y'all solve this, we're going to subtract 5. I'm going to get 11a equals that negative 5. And then our last step, divide both sides by 11. So that cancels out, giving me my 1a. Nothing I can do to that. So that's going to stay a negative 5 over 11. So there's my first answer. Now to get my second answer, I'm going to add 15. So this 5a will equal 15 now. And then come in, divide both sides by the 5. And let's see, that gives me what? A equals positive 3. So we really love them when they're already factored and they got a 0 here. But, you know, they're going to give us trinomials that aren't factored. So let's see what we do here. Solve c squared minus 7c minus 30 equals 0. Now, these will probably say solve by factoring. The ones in support are pretty much going to be factorable or square root stuff until they actually tell you on the last one to use the quad formula. So this one we're going to assume will factor. So we're going to come down with our parentheses. And it's all going to equal 0. So see, we're going to turn it into something like this when we factor. So we know what's going in the front of both parentheses because you got a c squared. And the only way to get a c squared is a c times a c. Now, the last one's negative. And while ago, I said if it was negative at the end, these factors are going to have unlike signs no matter what. So what I need y'all to do is find me factors. So find factors of 30 that subtract to get 7. So find me factors of this 30, y'all, that'll subtract and give me that 7.
10 and 3.
All right, so 10 and 3. Now, do you remember? The larger factor I said had the same sign as the middle number. So remember, the 10 is your larger factor. And the larger factor always has the same sign as the middle. So your 10 is going to be negative, and your 3 will be positive. Now, y'all, to check if you got the signs right, negative 10 and a positive 3, guess what? Negative 10 and positive 3, they equal negative 7. And then if you do 3 times negative 10, they equal negative 30. So they got to add to get the middle number, and they got to multiply to get that last number. All right, y'all, we're factored just like they were up here. So now take both of your factors and set them equal to 0. So let's see, we're going to subtract 3. We'll add 10. So guess what? My answer will be negative 3 and 10. So let me ask y'all this. Say you didn't know how to factor. Remember, I said you could graph this. So let me show you on the graph. Let's see, share calculator. I'm going to clear all this stuff out. So go to y equals and clear that out. Now that's c squared, but remember, I got to put x squared. So x squared minus 7x minus 30. So just remember, when you put the answers in, you want to use c's and not x's. But on the calculator, you got to use x's for your variable. But y'all want to graph it. Where do you think it's crossing the x-axis at? Well, guess what? That one on the left, that's -1, -2, -3. So remember, -3 was one of my answers. And then if we go right, 1, 2, 3, 4, 5, 6, 7, 8, 9. Look at that. 10. It crosses the x-axis at -3 and 10, which were my answers on that, okay? So if you're weak at factoring, graph it and it'll sort of help you out there, okay? Now, I'm not going to lie. The calculator, you're not going to be able to tell where them radical type answers are. But yeah, if it's something that factors, anything that factors, you'll be able to tell on the calculator where it's crossing. All right, y'all, here comes one of those with a number in front. Let's see what they're giving me. 3t squared minus 13t minus 16 equals 0. Now I'm going to solve this by factoring. These are a little trickier to find when you're graphing them, because when it's got a number in front, that means one of your answers will be a fraction, okay? So that's the only thing about when it's got a number in front. You're guaranteed at least one of your answers will be a fraction. And remember, the calculator's doing the x's by whole numbers. So here's what you got to do. Remember up here, the last number 30, I found factors of. But y'all, when you got a number in the front, your first step, you got to multiply the 3 times 16, which will give me 48. So we borrow the 3, we find our factors, and then we're going to divide that 3 back out in a little bit. So here's what we want. So remember up here, I looked at the last number. So for this one, I want y'all to find me factors of 48 that subtract, because remember that last one's negative, that subtract to get 13. So, oh, y'all look at this. What two numbers did I multiply to get to 48? 16 and 3. Guess what they subtract and get? 13. So my two numbers on that one are going to be 16 and 3. So let me show you what you're doing on this one. At the moment, we're not worried about the 3. The t squared will be a t and a t. Last one's negative, so one of these is positive, one's negative. Remember, 16 and 3, the larger number is the 16. So the 16 will be negative like the middle. So the 16 is going to be negative. The 3 will be positive. But y'all, the reason I left them like this, because once you got these two numbers, we got to divide that 3 back out of it. So divide each factor by the 3, which was the first number. Okay, you multiply the number to get your product, then you divide that number back out. So y'all, let me ask you this. Can you simplify this first fraction? All right, y'all, so let's think. 3 divided by 3, that's going to give me a 1 there. So this fraction did reduce. 3 divided by 3 gave me a 1. Now over here, 16 won't divide by 3. It won't reduce. So that's going to stay 16 over 3. So we are now factored. Now we're going to find our two answers by setting both of these equal to 0. Right, y'all, here I would subtract 1. P equals -1. Do you see, when you're doing this part, all you're doing is changing the sign. If your factor was positive, your 0 will be negative. So since this was a negative factor, this 0 is going to be positive because you got to add 16/3 to both sides. Okay. Now, y'all, they're really tricky with these 3s in the front. So if you pay attention, I'll show you how you can find these answers on this calculator. It'll do this factoring on there, so let me show you. It's a little tricky, but I'm going to show y'all. So I'm going to go to y equals and put that thing in. So let me clear that one out. So I had a 3t squared, which will be a 3x squared, minus 13x minus my 16. Now, let me show you the graph. So here's the one over here at -1 we got. Remember that 0, -1 we got. But this one is in between, let's see, 1, 2, 3, 4. This one's in between 5 and 6. But y'all, guess what? If you went to the table at the moment, by hitting second graph, and we go over to where the -1 was, we got a 0. But if we go up there where that 5 and 6 was, see, it goes all the way down to -6, but then it goes to 14. So it's not giving me the fraction yet. So I'm going to show you a trick I do. Since that was a 3 in the front, do y'all see this window button? Right above it, it says table set. I'm going to hit second window. So I'm starting it at 0. You see that little triangle table? That triangle means the change of the table. So right now my x's are going by 1. But y'all, since I had a 3 in the front, I want my x's to go by 1 divided by 3. So if you got a 3 in the front, you want it to go by thirds. If you had a 2 in the front, you would change it by halves. And so on. So make the fraction 1 over whatever your first number was. Now watch when I go to my second graph for my table. See how it's doing all the thirds? So let's go back to -1. There's my first 0 at -1. Now I'm going to arrow over here because I know that one was between 5 and 6, remember? So let me go on up. At 5, oh, look at that. 5.3333 gave me my second 0. Okay, so 5 1/3. That's 5 1/3, but if you change it to an improper fraction, you get 16/3. Okay, so trickier to do the table set. So now if I wanted it to go back to normal, I would go back to second window and I would start it at 1 or 0. And then I would set my table back at 1 down here. So when I do that, it'll go back to the regular 0, 1, 2, 3s, okay? Now only do that if you're really weak at factoring. But there's options you can use that calculator for, okay? But y'all, we're not going to kill y'all on those problems with the number in the front, okay? All right, y'all, so let's play with the square root property. We're going to solve 4x squared minus 28 equals 0. Well, we notice one thing. There's not an x term. So we have no x term. So since there's no x term, we're going to solve by taking the square roots. And what the thing about square root says, if a equals b, if you got two sides equal, then the square root of a will equal the square root of b. Basically, what they're saying is, hey, if I take the square root of one side of an equation, I got to take the square root of the other side. So here's the trick on these. To solve this by square roots, I need to get this x squared on one side by itself equal to my numbers. So we need to get the x squared term by itself. So to get this x squared term by itself, I'm going to add 28 to both sides. So I'll bring down my 4x squared. That's going to equal a positive 28. Now, get the x squared term. With a 1 in front of it. Well, to make that a 1x squared, I'm going to divide both sides by 4. So y'all, the 4's cancel. I got 1x squared now. 28 divided by 4 gives us 7. So now remember, to turn an x squared into an x, I'm taking the square roots. Of each side. So we're going to come in and do the square root of x squared equals. Now, y'all, since you're taking the square root of a number, you're going to put the plus or minus in front and then do your square root of 7. Because remember, the square root can come out positive or negative now. When you're younger, they only teach you about the positive square roots just to get you used to it. But now when you solve equations, you do got to take into account the negatives. So y'all remember when we did the inverses, that radical cancels with that exponent, leaving my x. So y'all, does that square root of 7 simplify with
No.
any of them perfect squares? So let me see my chat. So no, which it definitely doesn't. And the only one smaller would be a 4, but it don't divide by 4. So y'all final answer is plus or minus square root of 7. So you'll get the radical answers on these if they're not perfect squares, just like with the quad, okay? All right, y'all, solve 3x squared equals 6. So guess what? Once again, there's no x term. So I'm going to solve it by square roots. Now, I'm happy with the number being over there on this one because all I got to do is divide both sides by 3 and I'll have my x squared. So I'll divide 6 by 3. So the 3's cancel. We got our x squared. Over here, 6 divided by 3 gives me 2. All right, so now we'll take our square roots. And remember, that's now going to be a plus or minus square root of 2. So that cancels, giving me my x. So we know that'll be plus or minus. Well, y'all, can we simplify that square root of 2? And y'all guess what?
It doesn't simplify, so it's just plus or minus the square root of 2.
There you go. Yeah, that 2's too small for that one, right? All right, so y'all noticed if I don't have them x terms in the middle, the easiest thing to do with these is that square root stuff. So let's see what they got next. Oh, I like this one. 5x squared plus 10 equals 0. Now let's think, is this possible in the real world? Any number you squared will be positive. So a positive number times 5 plus 10. There's no way in the real world this is going to equal 0. So y'all watch what kind of answers I get on this. So we'll start out by getting that 5x squared by itself. So let's subtract that 10. Oh, and I forgot to say, once again, this one had what? No x term on it again, okay? All right, y'all, so 5x squared will equal that negative 10. All right, let's divide both sides by 5. Ooh, look at that, y'all. That gives me my 1x squared like I wanted. And negative 10 over 5 gives me a negative 2. All right, so now we're going to take our square roots of both sides and see what y'all do with this. So remember, that could be a plus or minus square root of negative 2. So this side, that radical cancels that exponent, giving me my x. And that'll be a plus or minus. So the question of the day, can I simplify that square root of negative 2?
Would it just be positive or the positive square root of 2 because the negatives cancel out?
Oh, well, remember, this negative's under that radical. So you can't multiply it by these negatives out here. So y'all, what? Remember, let's put this thing on the side. We got a negative 2 under that radical.
Is this when you're gonna do square root of -1?
Oh, look at you go. There you go. Square root of -1 times square root of 2. And then what do we say about that square root of -1?
It turns into an I.
It turns into an I. So that this is a plus or minus I square root of 2. See, in the real world, I can't square a number, multiply by 5 and add 10 and make that equal 0. So it's going to be imaginary numbers that can make that thing true, okay? So square roots and quadratic formula can give us these imaginary answers. And y'all just remember, anytime you take the square root of a negative number, you will get imaginary answers. So let's try one more, and then I'm going to do something different. X squared plus 81 equals 0. So once again, there's no x term. So I'm going to take my square roots. So first, let's subtract 81. So I get x squared equals that negative 81. Let's take our square roots now. So, y'all, this side cancels out with the exponent. I got my x. Whoops, we know that's going to be what, a plus or minus? So, y'all, plus or minus what? What's the square root of a negative 81? Oh, and I'll give y'all a clue. That 81 is a perfect square. It does have a square root.
So 9.
9 what? Because I see a negative under there.
Imaginary I 9.
So negative plus or minus 9i. There you go. Because remember that on the side, that square root of negative 81, I would break out that negative 1 and 81. Well, the square root of negative 1, me said, was I. But y'all, the square root of 81 is a 9. So this gives me I9. Now, the traditional way they do it, they always put the number first and then the I. They put i's in front of radicals, but if it's a whole number or an integer like that 9, they always put the I second. Y'all, let me show you. Let me see if my calculator's all hooked up here. Let me quit that screen. Clear that. So where's my square root second? X squared for a square root. Negative 81 and enter. So see, right now it's saying non-real answer, which means it's going to be imaginary. But y'all watch this. If I want it to do imaginary numbers, you can hit this mode button here and go down here where it says real. We're going to take it off of real and we're going to highlight the A plus BI and hit enter. Remember, A plus BI a while ago, I said that was my real numbers and my imaginaries. That's what we call a complex number. But if I highlight that, and now I go back and do second x squared to get my square root and do negative 81. Watch this. It gives me the 9i. So you can do the perfect squares on here that are negative if you switch the mode, and then it will give you those imaginary answers, okay? If you have it in the real world, then it's going to tell you, hey, it's going to give you an error because those aren't real answers, okay? So just things you can do. And I can actually, yeah. Okay, heaven, that's cool. I can actually leave mine in A plus BI mode and it not hurt anything. Okay. All right, y'all. So I wanted to do one more with you. And then I'll let y'all out of here. So my X and Y. So let's see, I got my 1, 2, 3, 4. I'm gonna go out about 5 everywhere. All right, so let's say this thing's crossing over here at -3. And it's crossing over here at 5. So let's see. I gotta draw this parabola coming down and up. So for this graph, first thing I want are the x-intercepts. Once I got my x-intercepts, we're going to find the zeros. So anyone want to guess what these two x-intercepts are?
-3 and 5.
Oh, you're so close, but make them a point. So what's the y value?
-3, 0, and 5.
Okay, there you go. And then you said what 5 was my other one? So 5, 0. So make sure when y'all do the x-intercepts, you write them as these ordered pairs on there, okay? So now if these are the x-intercepts, what are the zeros?
-3 and 5.
-3 and 5. Okay, y'all, so that's all the support's going to do. They do got one using the quad formula at the end. So let me show you what you got to do to this one, because it's looks different than what you've been doing. So we'll do one more quad and we're out of here. So you're going to solve 2x squared plus 2x equals -5. And really, all I'm worried about is what you would do first to that.
Add 5 to both sides.
Oh my God, you're the first one that got that.
Oh, it would be add 5 to both sides to set it
Yeah,
to
you would, because you need what over here?
a 0.
A 0. Yeah, last night they was stumped on that, y'all. Good job. So 2x squared plus 2x plus my 5 all equals 0. And now I'm in descending order, so I can now figure out A, B, and C. But y'all, if you left that 5 here and you put -5 for C, you're going to miss it and do a lot of work for nothing. So A would be 2, B is 2, and C would be a +5. All right, so here we go. Negative B, which is 2, plus or minus 2 squared minus 4 times 2 times 5 all over 2 times 2. Now let me see one thing about this one. Alrighty, so get y'all more practice on this. So -2 plus or minus. All right, let's see. 2 squared is 4. And y'all, sadly, there's only one negative over here. So that's going to stay negative. Woo, let's see. 2 times 5 is 10 times 4. That's going to be 40 all over 4. All right, y'all. So -2 plus or minus square root. 4 minus 40 is going to give us a -36 over our 4. So let's see. What is the square root of that -36?
Imaginary I in the square root of 6.
Oh, you're so good. But once you take the square root of 36, get rid of that radical. So that'd just be what, a 6i
6i.
all over 4. So here's the thing. I'm going to reduce these numbers down, and then remember, since it's I got to write it as a complex number. So let me bring that up right here. All three of these will reduce by 2. So -2 divided by 2 gives me a -1 plus or minus 6i divided by 2 gives me a 3i. And then that 4 divided by 2 gives me a 2. So now I've reduced it. Now we got to write a plus bi form. So remember, that's going to give me 2 fractions. The real part will be -1 divided by 2. Then we'll have our plus or minus. And then my imaginary part will be the 3i over 2. Or you can put 3/2 and the I after it. It don't matter where you put the I. As long as it's either on top of the fraction, or you could do this, -1/2 plus or minus 3/2 I. Okay, the only thing you can't do is put the I on the bottom of that fraction. And anytime you get these with imaginary, you got to split them apart. Okay. Alrighty, also remember, if these are perfect squares under here and they're negative, they're just going to come out as the 6 and then the I, like we did a while ago. I forgot what we had, negative something. So this is an exit quiz for you right here. Just to see if y'all get these before I let y'all out. What is the square root? -25.
5 imaginary.
5i.
And all y'all got to say is what? 5.
5i.
And then we all know these would be what? Plus or minus. All right. How about this one? Square root of -121. So that'll be a plus or minus what?
It's gonna be plus or minus 11i.
11i. Good job. Square root of, what's another square root? How about square root of 49?
It's gonna be plus or minus 7.
Oh man, I couldn't fool you, could I? I was doing the eye to eye last night. Last night I did this to them. They said, "Oh, plus or minus 7i," and I was like, "Huh?" Okay. So y'all are on your game early in the morning, okay? But y'all, that's solving quadratics. We did 3 ways. We did the factoring, the square roots. Those 2 are my favorite if I can factor them, and if I ain't got that x term. And then, if nothing else, the quadratic formula will work on every single one of them, okay? All righty, y'all. So, questions on those. So listen, Thursday morning we'll knock out 4, 8, and 7, 5. 4, 8's pretty short. But y'all, let me think when it was. What was yesterday? Monday. Yesterday I sent y'all an email out. It's bonus points for test 1. So if you want bonus points for test 1, it's 3 little questions you got to do, and it's worth up to 10 points, and that's almost a letter grade, okay? So that would turn 70 into an 80, 90 into 100, and so on. Now, the only catch is the highest I can make a test is 105. So if you made 100 on that and you do the bonus, the highest grade I'll give you is a 105. But I'll put the other 5 points on a quiz or something. Okay. So, yeah, y'all get me that done by Sunday if you want the bonus points. Soon as I get them in, I've been adding them and rolling through them, okay? So it will pull you up by at least one letter grade if you get all three of those, okay?